Hey, welcome to our notes today. We are going to do the 8.4 notes, and this is our last lesson in this unit, and we are going to be talking about some proportionality theorems. Okay, so we already know the vocab words that are here, so let's skip right to the theorems. We have theorem 8.6 called the triangle proportionality theorem, and then we have theorem 8.7, which is the converse. So let me just zoom in a little bit more to this picture, and I'm just going to read what it says in the theorem. The theorem says if a line, which I'll show here, if a line is parallel to one side of a triangle and it intersects the other two sides. So here's TU. So if TU is parallel to QS and it intersects QR and SR, then what it's saying is if you look at RT, which here is in yellow, and then compare that to TQ, look at their ratio. That ratio will be the same as the other two parts on the other leg. Okay. So that is what the theorem says, and I'll read it verbatim here. If a line parallel to one side of a triangle intersects the other two sides, then it divides the two sides proportionally. And then there's the converse. The converse, let me go down here, says if a line divides two sides of a triangle proportionally, then it is parallel to the third side. So if we have these two little sections here, let's say RT and TQ, right there ratio. And then we find the ratio of RU and US. So then we set up that proportion. If they are proportional, so the two ratios are set equal, then we know that the two sides here, RTU and QS, those are parallel lines. All right, there's the first two theorems. Third theorem says if three parallel lines intersect two transversals, then they divide the transversals proportionally. This is called the three parallel lines theorem. So recap, we've had the triangle proportionality theorem, and then we've had its converse. Okay, so the triangle proportionality theorem says if you have a triangle and there's a line on the inside that's parallel to a side, then it's going to break up the sides that are divided proportionally, and then we have the converse. Now we have three parallel lines theorem, so this does not deal with triangles. It just says if we have three parallel lines and they're intersected by two transversals, then they divide the transversals proportionally. So let's look at what they have here in terms of a picture. If we look at the picture here, they're showing that because we have three parallel lines, lines R, S, and T are parallel. If we look here, UW, this section here, when we compare it to WY, so that's going to be UW and WY, it's going to be the same ratio as the corresponding sections on the other transversal. Okay, so that'd be VX and XZ. And then our last theorem is called the triangle angle bisector theorem. That's this whole one here. So the triangle angle bisector theorem states if a ray bisects an angle of a triangle, so notice we have two congruent little itty bitty parts here of this angle. So this ray, CD, is bisecting angle C. Then it divides the opposite sides into segments whose lengths are proportional to the lengths of the other two sides. So if we zoom in right here to show you what this looks like. So we have an angle bisector. That means now we can compare, what is this, AD. If we compare these two parts that are being divided by that ray, look at their proportion, their ratio. It's going to be proportional to, notice, the leg that touches AD, which is CA, is going to be compared up here. That is going to be the same ratio as CB over on this side. So we have these two right here are going to be the same as these two right here. So that proportional part. So let's go ahead And I think it'll be easier when you see this in the practice rather than me just trying to talk through the theorem. So let's just see this in action here. So let me zoom out so you can see what's going on here. Okay. In exercises 1 and 2, find the length of AB. So AB, I'm going to put a little X right here because I have no idea what that is. And remember, because we have, notice here, I have two parallel lines in a triangle. Our triangle proportionality theorem says that these sections right here, X and 6, if I write those X over 6, that ratio is going to be proportional to the corresponding parts, which would be 5 and 10. So we're going to put 5 over 10. So when I solve, I'm going to get that X equals 3. So we can multiply both sides by 6, and you get X equals 3. All right, and number 2, AB, we'll write that with an X. So I'm going to make my proportion X over 7, that's the same side, is going to be equal to my 2 over 9. The reason why it's 2, because 2 corresponds with x, so they have to correspond with each other in the fraction. Multiply both sides by 7, and you get x equals, yes, a really nasty fraction, 14/9. All right, let's go to the next page. Now it says determine whether these line segments AB and XY are parallel. So remember, the converse says they will be parallel if the sides that are divided are proportional. So let's look at the two parts here. We want to check if what I have here in blue is parallel to what I have here in red. So I'm going to look at the same side. So I'm going to look over at this side first. I want to compare my 3 with my 4 on that side with the 4 and the 5 on the other side. And are these fractions the same? No, they're not. So that means they are not parallel. Now, if we look at number 4, again, we're trying to check if AB is parallel to XY. There, what I have in yellow. So I'm going to focus on my 6 and my 4 being together. So is 6/4 the same as 7.5 over 5? Now what happens is I'm going to have to put those in the calculator, all right? If I put those in the calculator, I get 1.5. So 6 divided by 4 is 1.5. And then 7.5 divided by 5 is also 1.5, which means, yes, they are parallel. And that is because of the converse of the triangle proportionality theorem. Now, let's look at numbers 5, 6, and 7. A little easier to see. We get to use our 3 parallel lines theorem here to fill in these following ratios. So let's look what we have here. And I'll probably do a lot of erasing. Let's look at UV. So here's UV. And then I want to compare that to UW. So I'm going to look at the other side where the other transversal is, and I want to look at what is in the same spot as UV, that is XY, which I have down here. Okay, I'm going to do this in color. But what's the same spot is from X to Z, and that's what I'm going to have to put in this box down here, is now I want to find XZ. So again, I'm going to probably erase some of these colors just to help. And now let's look at number 6. We want to look at XY. So XY is this section, and we're comparing it to YZ, which is the bottom section here. So let's look at, let's make sure this is true. Is VW the bottom section? Yes. So notice what we want to look for is the corresponding section with XY, which is now UV. I'll make this UV. Now we have one more to try here. And do some erasing. And let's look at the right side of this proportion first. I'm looking at WU, which is the whole part. And then I'm looking at WV, which is the smaller part here at the bottom. Okay. I'll make these, here's my colors. I didn't highlight them this time. Now, just double check. ZY is this bottom section. So I'm going to compare that. If that's the denominator, my numerator has to be the red section, which is this whole length here, which is from X to Z. Here we go. All right. Last two example problems are going to be with our triangle angle bisector theorem. And so we have this angle bisector, but when it's in the triangle, it states here, I'm going to zoom in just a little bit on this one problem, that now that I have my angle being bisected, it says that the proportion of x, when we compare that to the other bottom, which is 5, so x over 5, we can set that equal to the ratio of the two sides. Now notice what number is with x. It is 9. So I'm going to put 9 on top, and with the 5 is 15. When I solve, I'm going to get that x equals 3. So the two bottoms, their ratio is equal to the two sides. That's the proportion that we're setting up. So if we look at number 9 here, do the same thing. Now we have an angle bisector, but notice we have the whole side is 14. So we have to think, if the whole thing is 14 and this is B, how do you get the unknown part? Well, you can take your total minus your part and you're left with the part you don't know. So I'm going to write in here that this is going to be 14 minus B in that section. So I can say 14 minus B when I compare it to the B side is equal to, well, what's part of the triangle is with 14 minus B? It is the 6.75. I'm going to compare that to the 9. So what we got to do is we have to do some cross multiplying. I'm going to model this. If I cross multiply, put parentheses here, and we're going to get 126 minus 9B equals, multiply the other way, 6.75B. Now, if you continue going, you get B equals 8. All right, there's your notes. If you have any questions, reach out. If not, we'll see you either in the next video or in class. Have a wonderful day.